Hey, fifth grade friends, this is Miss Stacy. We are reviewing Monday's math homework. Fill in the blank to make each question true. So we know that if we are going from 36 to 3,620, we are going to be increasing the value of the 36 and 2/10. So we are going to have the decimal point here. So that means that we're going to move that decimal point 2 times to the right, and we will be multiplying 36.2 times 100. And again, when we do this, we check, we move it 2 times to the right, include that 0, and we have 3,620. Okay, next we have a value of a whole number of 3. And then we have 35,700. So again, we are increasing. So we're going to move that decimal point to the right. And if it is here, we're going to move it 1, 2, 3, 4 places. So that means we are going to have 1, 2, 3, 4 zeros. So we're going to multiply by 10,000. And again, checking your work by solving 1, 2, 3, 4, add those 2 zeros. So we have 35,700. Okay. Next, we have a whole number of 2 and then 2,050. So we will be multiplying and moving the decimal point to the right. So if it is here, we're moving it 1, 2, 3 times. 1, 2, 3, so 1,000. So when we check, move it 1, 2, 3 times, we have 2,050. So we'll be multiplying by 1,000. Okay, we now have not even a whole number, but here we have 2, so we're increasing the value again. So if we move the decimal point 1 time, that will be times 10. So if we check ourselves, multiplying that by 10, we move it 1 time for 2 4/10. Use the terms sometimes, always, or never to make each statement true. So our first question says a rhombus is blank a square. So if we remember our robot road, we know that going down the chart, a rhombus is sometimes a square. Why is that? Why is it not always? It's because a rhombus does not always have 4 right angles. So this will be sometimes. Okay, the next one is a trapezoid is blank a parallelogram. Well, we have to know what a trapezoid is and what the characteristics of a parallelogram are. So if we look at here at the parallelogram, it has opposite sides of equal length and that are parallel. Well, we do have one pair of parallel sides, but they are not of equal length. So it does not match the description for a parallelogram. So a trapezoid is never a parallelogram. And C, a square is blank a rectangle. Well, if you know that a square has 4 right angles and all equal sides, a rectangle has 4 right angles and opposite sides are parallel and equal, then we know that a square can always be a rectangle. But can a rectangle always be a square? And the answer would be no. Because a rectangle, for it to be a square always, would have to have all sides equal. Julia ran 4 2/5 miles. Sally ran 3 1/4 miles. How many miles did they run all together? So we know we are going to be adding. So our expression would be 4 2/5 miles plus 3 1/4 miles. And before we can solve, we need to either come up with a common denominator and then add, or we need to convert each of these mixed numbers to an improper fraction, and then we could find a common denominator and add, or butterfly. Or we could look at the whole numbers and add the whole numbers first, and 4 plus 3 is 7. Then we can use just the fractions and we can find a common denominator, or we can use the butterfly. So if we butterfly, this is 5, 8, and 8 plus 5 is 13. And then 5 times 4 is 20. So then we have to include the whole number and the fraction. So together they ran 7 and 13/20 miles. And if you found a common denominator, you could use 20ths. So we know that this would be 8, equivalent to 8/20 plus 5/20, which would equal 13/20. It's just the same. Determine the placement of the decimal in each product. So we don't have to multiply because they're already giving you a product, but the product is not correct because we need to place the decimal in the correct place. So we know that if we have hundreds here, we know we're going to have to include that in our answer as well, in our product. So we would move the decimal point 2 places. And so the decimal would be placed at 52 and 32/100. Here we have 1, which is a tenth, but here we have hundreds. So if we have tenths times hundreds, that would be thousands. So we know we want to move it 3 places to the left because that's 1, 2, 3. So 1, 2, 3. So our value is 44 and 785 thousandths. Okay. Here we have hundreds and tenths again, so that would be thousands. So we will move it 3 places to the left, and our product will be 1 and 875 thousandths. And finally, we have tenths times tenths, so we know that's going to be hundredths, 1, 2 places. So our product will be 7 and 56 hundredths. The location of the park in Allison's town is shown in the coordinate grid. To get to the park, Allison left her house, went 5 units down, and 2 units left. So she went 5 units down and 2 units to the left. And she is going from her house to the park. So what are the coordinates of Allison's house? So if we're going from the house to the park, 8-1 represents the park because it says that the park, the location of the park is shown on the grid. So this is our park location. Okay, and so we're going to have to go backwards from the park because she's really going from the house to the park. So instead of going down 5, we will be going up 5. And instead of left 2, we will be going right 2. So let's see where that places us. And remember, since we are going the opposite direction, these would have to be in reverse order. So you are really going to go from the park to the house. And we're going to go to the right 2 and then up 5. Right, so let's see where that will take us. So from the park, we're going to go to the right 2, 1, 2, and then up 5. 1, 2, 3, 4, 5. And that location will be at 10, 6. So the house will be located at 10, 6. All right, guys, till next time.